Hello guys, right, so I'm just going to make this video for you to talk you through the construction of your 2D game in Unreal Engine. I'm going to start from the beginning, so feel free to just sort of like skip through and find where you need to be. What I suggest you do is like watch a little bit, pause it, do the thing that you need to do, and then continue on with the video and do it that way. I'm going to go through the whole thing. I'll try and get through it as quickly as possible, but let's just make a start. So, in the content browser, I'm just going to turn on the sources panel so I can navigate easily, and I'm going to set up a new folder for my blueprints, and we're going to start off with the 3 blueprints that we need. So I'm going to right click in the content browser, go blueprint class. I'm going to start off with the game mode. I'm going to call this BP underscore game mode. I'm not going to explain everything because we've done a lot of this in class, so I'm just going to quickly go through it all for you. The next blueprint class is a player controller. Just check that I spelled that correctly. It did. And the last one is our paper character, which we need to go into all classes for. I'm just going to search for paper character. There it is. And I'm going to call this BP player character 01. Right, okay, in the game mode, we're going to open that up. And we are going to come over here. If your game mode blueprint opens and it doesn't look like this, there should be some blue text at the top of the screen which says open in full blueprint editor. Just click that blue text and you'll see this. Not that it matters, but it could be useful later. Right, we're going to go into the player controller class, and we're going to set our player controller for that. And then in the default pawn class, we're going to hit the drop down and we're going to choose our BP player character 01 for that. So player controller class becomes BP player controller, and default pawn class becomes player character 01, which will compile and save that, and we can close it down for now. We are now going to set up our project settings to use the game mode that we've just created. If your project settings aren't open, just go to settings and choose project settings, and then over on the left hand side where it says maps and modes, we're going to go in there, and the default game mode we're going to set to the BP game mode that we just made. Do that and we're all done. Right, next step, let's start bringing in our sprites. I've got them saved in a folder here. We can just import them all at once. So first of all, I'm just going to go back to my main content folder, right click, create a new folder, call this sprites, double click, and I'm literally going to just import them all. We're not going to need them all, but we might as well bring them in. So I'm just going to highlight them, drag and drop. When they come in, all of the sprites are going to be selected, so we might as well take this opportunity to right click on one of those sprites, go sprite actions, and apply paper 2D texture settings, and they're all ready to go. I think that's probably done them all. Let's just quickly dive in. Yep, that one's got the paper 2D texture settings. Fantastic. Anytime you do use a sprite, if you haven't already, just make sure that you do right click on them and choose sprite actions and apply paper 2D texture settings. Right, okay, let's get our character set up now that we've got our sprites in. This is the player start point, by the way. This is where your player is going to spawn in your level. Right now, if I press play in new editor window, we just spawn in as a camera. We can't move, we can't do anything at all. So press escape, jump out of there. Right, let's go back to blueprints, let's go to the player character, and let's set up our character. Dock that there. First thing I'm going to do is just add a box, sorry, not a box, a cube. And this will just be a temporary version of our character as a placeholder. I'm just going to scale it to generally fit inside that capsule component. Doesn't have to be perfect. This is just going to be a representation of our character. I'm also going to add in an arrow. So I'm going to add component and arrow. And this arrow, I'm just going to move it up a little bit, is just for us to see which way is forward for our character. One thing that I'm going to do is just turn off hidden in-game and that basically means that the arrow will render. If we don't turn that off, we won't see the arrow. This is just for testing our character, so we can see which way the character is facing when we come to rotate the character. Alright, okay, so now that we've got that, I'm going to make sure that I've deselected everything over here in the components list, and I'm going to add a spring arm. The spring arm is what the camera is going to be attached to. There it is, created there. And then with the spring arm selected, I'm going to add a camera. The reason that I had the spring arm selected is so that the camera automatically parents to the spring arm. So now when I rotate the spring arm by selecting it, coming over here to the transform options, and in the Z axis for rotation, putting in -90, you can see that the camera rotates with the spring arm. Compile and save that. If we press play now, you can see that it's using our camera. We can't move yet, but we can see our cube and our arrow. I think what I'm going to do right away is push that spring arm back. So over here with the spring arm selected, I'm going to find the camera settings, and I'm going to change the target arm length to, let's say, 1200, and you can see that that has made the spring arm much longer. We can compile, save that, press play, and you can see now that we're viewing our character from a much further distance. Another thing that we can have a look at as well is the socket and the target offset. If I increase the socket offset by 100, you can see that the camera has raised up by 1 meter. So I'm going to push it up to 200, compile, press play, and I've got a little bit of a better angle from which I'm viewing the game. So I'm going to stick with that, I think. Press escape and jump out. Right, let's get this character moving now. First of all, we need to set up some inputs. So we're going to go back to our project settings. Again, if you can't find them, just go settings, project settings, and we're going to scroll down to input. Once we've found input, we're going to set up an action mapping for jump and an axis mapping for move right. So we'll start with the action mapping, hit the little drop down, we're going to name this jump, and we're going to select the key that we want to bind it to. Because we're using the keyboard, we can just click this button here and then press the button that is relevant. In this case, it's going to be spacebar. You can also search for that. I'm just clicking on there and search for spacebar and choose it that way. Next is the axis mapping. We're just going to create one of these. So I'm going to hit that plus button, hit the little drop down, hit this drop down. We're going to give this axis mapping the name of move right. You do not need 2 axis mappings, you just need one for move right. It works on a scale. So for the first button, we're going to choose D with a scale of 1, and for the second button, I'm going to choose A with a scale of -1. So 1 is going to the right, -1 is going to the left. In other words, D is going to the right, and A is going to the left. So we've got our input set up now. Let's go back to our played character, and we're going to go into the event graph. I can get rid of these default events here, and we'll start with jump. So I'm just going to right click in a bit of empty space, search for jump, and what we're looking for here is the action event jump, and that'll give you this red box here. From pressed, I'm going to pull that pin out, and I'm going to search for jump. Compile and save that. Press play, click on the screen. If we press spacebar now, that character can jump up and down. Great start. Next, we're going to set up move right. So I'm going to right click again, I'm going to search for move right, and we're looking for the axis event move right. That's going to give us this red box here. From there, we're going to take the pin out, and we're going to search for add movement input. We are going to take the axis value from our move right event and plug that into the scale value in the add movement input. And for world direction, in the X, we're going to put in 1. That means our character will move on the X axis. We can compile and save that, press play. Our character can now move to the left and to the right and can jump as well. Very good. Okay, next we need to get the character to rotate. So to do that, we just to the right of our add movement input, we're going to right click and search for get player controller. We're going to take the blue pin out of the get player controller, and we're going to search for add control. Is it add? No, it's we're going to search for control rotation. and we're going to set control rotation. We're going to plug that in. No, we're not. We're going to leave that there. We're going to have two of these, one for moving to the right and one for moving to the left. So to set the control rotation, we need a rotational value in there. So I'm just going to right click on new rotation and split the struct pin. For moving to the right, we do just want the rotation to be at 0, 0 and 0. The only value that is relevant is the Z value, which is yaw. But for moving right, we just need that to be at 0. We're going to do this again, so we'll take the blue pin out, search for set control rotation. Move that up there. We're going to right click on new rotation, split it, and in the new rotation for the Z, we're going to put in 180 degrees. So when we move to the left, we're going to rotate the character 180 degrees on the Z axis. Now to do this, as we change our axis value, so as we press D and A, our axis value goes from 1 to -1. So we're going to use that number to check to see whether we should rotate to the right or to the left. So from add movement input, we are going to pull the pin out and search for a compare float. And then we're going to take the axis value from move right and plug that into the input. You can, if you like, double click on that line to create a couple of reroute nodes, which just keep things nice and neat for you. From the top symbol, which is more than, we're going to plug that into our first set control rotation, and then the bottom symbol, which is less than, we're going to take that out and plug that into our second set control rotation. I'm just going to move things around to keep it nice and neat, and just add a couple of reroute nodes so that it's nice and readable. Alright, let's compile and save that, and we'll see what we get. This is the result. Now what you're seeing here is I am actually pressing A there, and D, A, and then D. The character looks like it's not rotating because it seems to be always traveling to the right, but it is. The issue is that the camera is also rotating with our player. So to fix that, we're going to select the spring arm, and then over on the right hand side, we're going to turn off inherit, roll, yaw, and pitch. Like I say, the only relevant one is actually yaw, but we might as well turn them all off. So we'll compile and save that, press play, and then as we press A and D, we can see our character is moving left and right. It is rotating, and the camera is no longer rotating with the player. So there's the basic setup for the character done. We can tweak a few things so the character feels quite floaty and a little bit slow to me. So I'm going to press escape, and back in the player character, I'm going to choose the movement component, and we can change how our character moves around. So first of all, I'm going to increase the gravity scale to 5, and then if I do that, you can see that the character's jump is very, very low now. So we are going to go back to that character movement component, scroll down until we find the jumping falling section, and we're going to change the jump Z velocity, which is basically how high your character can jump. I'm going to take a guess and say 1200 for that. Compile, save, press play. Alright, that's feeling a little bit better. You can see the character kind of feels more weighty now. It can jump to a reasonable height. You can obviously adjust these numbers to whatever you wish. For me, I don't want the character to gradually accelerate and decelerate, so I'm going to change that too. So back to the character movement component. I'm going to scroll up to the general settings to start with, where we have max acceleration. I'm just going to turn that up very high and put 4 9s in there, and then in the walking section under braking deceleration for walking, I'm going to change that to 4 9s as well. We can also change the max walk speed, but we'll have a look at that in a second. So if I press play now, you can see the character accelerates and decelerates very, very quickly. It's starting to feel a little bit more solid now. Lastly, you can also change the maximum walk speed, currently at 600. If we double that value, you'll see that our character now moves at a much higher rate of speed. There is one more thing that we can have a look at, and that is air control. So at the moment, if I jump up and press a button while I'm in the air, I can't really move very much while I'm in the air. So what we can do, I think this is under jumping and falling, there it is, air control. To have 0 control of your character in the air, you would set that value to 0. To have maximum control of your character in the air, you would set that value to 1. As you can see, if you hover over, you can read the tooltip that explains how that works. So I'm going to actually set mine to 1 so you can see the difference. So now when I jump, I'm able to move my character almost as much as if I was on the floor. And it just means you've got a little bit more control over your character, which is nice for platforming, I think. Alright, that'll do for that. Okay, we've got these done. One thing that you can do to keep things nice and neat is just highlight all of the work that you've done so far, press the C key and just give this a name of movement, and it just keeps things nice and neat for you in your blueprints. We'll compile and save that. Let's go back to the main screen, and we are going to set up our character animations to get our character moving. Well, we've got our character moving to make it look like our character is running and jumping and so on and so forth. So let's get the sprite set up. So we're going to go into main characters. I'm going to use the virtual guy character for this, and you can see that we've got some sprite sheets for double jump, fall, hit, idle, jump, run, wall jump. Obviously we are going to use idle and run, and just for this demo I'm just going to use the double jump animation for jumping, which is like a kind of somersault, but we'll start with idle. So I'm just going to double click to open this up so you can have a quick look, and you can see that this is separated out into a series of different sprites that we need to extract. So to do that, we are going to, first of all, I'm going to set up some folders for the animations. So I'm going to right click, create a new folder, call this one idle, and then again, new folder, run, and then again, new folder, jump. Let's get the idle frames out. So I'm going to just right click on the idle sheet, sprite actions, and extract sprites. It'll automatically go into auto mode, but in this instance we want to use a grid. These are already set up for us to use, so I'm going to change it from auto to grid, and in the cell width I'm going to change that to match the cell height, which is 32. You can see we've got some nice even cells there, so we'll just extract those. There you can see we've got all of our individual sprites there, so I'm just going to click and drag and drop them into the idle folder and choose move here. Let's do the same thing again for our run. So I'm just going to right click on run, sprite actions, extract sprites, change it from auto to grid, and then 32 in the width, and then press extract. I'm going to grab all of my run sprites and move them into the run folder. And then lastly I'm going to do the double jump. So right click, sprite actions, extract sprites, change it to grid, and then the cell width can go to 32, extract. Grab our frames, move them into the jump folder. Alright, let's create some flipbooks with our sprites now. So we'll double click to open the idle folder. I'm going to highlight all of my idle frames, right click, and then right at the top I'm going to choose create flipbook. I'm going to give this the name of FB for flipbook idle, and we can double click to open that up, and you can see we've got a nice little animation which is currently running at 15 frames per second. I'm going to change mine to 24 and press save. Let's do that again for our other animations. So we've got jump, highlight them all, right click, create flipbook, call this FB jump, double click to open it up. Let's speed that up to 24 frames per second as well. Save it, close it down, back in here, and we're going to go for the run frames now. Highlight them all, right click, create flipbook, FB underscore run, double click to open it up. Let's change that frame rate to 24 to match all of our other animations. Right, we can save that. Cool, so we've got our flipbooks done now. It's time to start setting up the animation state machine for our player character, so that we can display some of these animations on our character and get rid of the cube and the arrow that we put in temporarily. So let's go back to our player character blueprint, and we're going to go into the viewport so we can see things a little bit now. I'm going to delete the arrow, I'm going to delete the cube, I'm going to select the sprite component, and under source flipbook I'm going to change that to our idle animation, so that will just replace our cube. You can see that it's very, very small, so I'm going to change the scale on the X, the Y and the Z to 5, 5 and 5. If we compile and press play now, you can see that we have a little character instead of a cube, which is lovely. Later on we'll make some adjustments to the capsule component. In fact, we could probably do that now. So I'm going to select the capsule component, and then under here for shape we're going to change the height so that it's closer to our character. So I'm actually going to go for like 55 height and a 55 radius. What you can see now is that the character's feet are below the capsule, so if I press play you can see our character is now sunk into the floor. So I'm just going to select the sprites and nudge them up and just check to see if the character actually stands on the ground correctly, which it does, so I'm quite happy with that. Right, now we need to set up the animations for our character. So to do this, our animations are going to be driven by whether our character is in the air, whether our character is moving. So obviously if the character is not in the air and not moving, we will play the idle animation. If our character is not in the air and is moving, we'll use the run animation. And if the character is in the air, we will use the jump animation. So we need to make sure that we're recording all of that information in variables. So let's go into the event graph, and we could just run this on tick. I wouldn't normally suggest using tick too frequently, but it's fine in this instance. So in a bit of empty space, I'm just going to right click and search for event tick. An event tick basically fires all of the time, so it's constantly going to be checking to see whether our character is in the air or whether our character is moving and so on. So from the event tick, just underneath, I'm going to right click and search for is falling, and we're going to get this information here. So you can see is falling comes from the character movement component, and it gives us a boolean in return. I'm going to right click on that return value, and I'm going to promote it to our own variable, which I will call is in air. So what that is doing is on tick, which is constantly, it's checking the character movement component to see if our character is in the air, and then it is storing that information in a boolean over here. The next step is to record our character's velocity. So let's right click and we're going to search for get velocity. From velocity, which gives us a vector in return, we are going to take that yellow pin out and we are going to get vector length. I'm just going to search for vector length. I don't think it is get vector length. Let me just spell that correctly. Yeah, sorry, it's not get vector length, it is just vector length. That gives us a float in return, and just like we did with this boolean over here, we're going to right click on there, promote it to a variable, and we will call this one oh sorry, yes, we're not going to promote that to a variable. That was my mistake. If you did do that, just delete that. What we are going to do is we're going to compare this float. So if this float is more than 0, we're going to convert that into a boolean, which will determine whether our character is moving or not. So essentially, if this number goes above 0, we know that our character is moving. So we're going to take the float value out of there. We're going to search for a compare float. We shall plug that in. No, we're not going to do that. We're not going to do that at all. What we are going to do is we're going to search for a more than symbol. I do apologize. So we take, just to be clear, we take the float value out and search for the more than symbol, which is shift and full stop on your keyboard. We're looking for float is more than float. That's going to give us our boolean in return. We're checking to see if this value is more than 0, and if it is, we want to just right click on that boolean there, promote it to a variable. We're going to name that variable is moving. So this gives us the information we need to feed into our character's animation state machine to determine whether the character is moving or is jumping, and then we use that information to play animations based on that. So the next step from there is to set up something called an enumeration, which is basically a list, and this list is going to be a list of the possible animations that our character can display. So if we go back to our main window here, we'll go back into the blueprints folder. If we right click, okay, that's an interesting bug. Okay, I can see it on my screen up there, so I'm going to have to... On my screen, this is completely black. On my recording screen, I can see it. So let's see if I can manage here. So we're going to go blueprints, and does that say enumeration? Yes, it does. We're going to create an enumeration, and I'm going to call this enumeration enum underscore animation states. I'm going to double click to open that up, and I'm going to add 3 things to my enumeration. So 3 enumerators. So up in the top right hand corner, I'm going to click on new 3 times, and then from there I'm going to call these enumerators after my animations. So I'm going to call the first one idle, and the second one will be called run, and then the third one will be called jump. Okay. I am going to pause my recording here and then restart because it's proving difficult for me with my UI bug. So if you can bear with me, I shall do that now. Okay, back in action now. Bug is gone. I may have to do that again. The hazards of using an ultra-wide monitor, apparently. So once we've set up our animation states enumeration, we can save that and close it down. The only time we'd ever need to come back to this is if we wanted to add more animations, which we won't be for this particular project. So close that down and get rid. Okay, time to set up our animation state machine, which is a brand new function. So back into our player character now, and over in functions we're going to just hover over here, and you can see that we can add a new function. First of all, it's going to ask you to give that function a name, so we shall call it animation state machine. Can't see. Animation state machine. We need to set up some outputs for this function. So over on the right hand side you can find outputs. Create a new one, and we're going to call this output the output flipbook. And we need to change the type of output that it is. By default it's a boolean. We don't want that, so we're just going to click here and search for a paper flipbook. Just need to spell that correctly. Paper flipbook. Hover over paper flipbook, move over and make sure that you choose an object reference. We're going to now just move this node way over here because we're going to need some space to do what we need to do. So this function is going to fire off. It's going to check to see if is in air is true. If it is true, it's going to set our flipbook to the jump animation. And then if it's false, it's going to check is moving. If moving is true, it's going to set the animation to our run flipbook. And if moving is false, it's going to set our animation to the idle flipbook. So we're going to come over here to the start of the function. We're going to choose is in air, drag that in and select get. We're going to take the pin out of is in air and search for branch. Let's plug that into the start of our function. So we're going to say, right, if is in air is true, we need to do something. And the thing that we need to do is access our enumeration. So to access our enumeration, we need to add a new variable. So over here on the variables list, I'm going to hit the plus button to create a new one. And I'm going to call this one the animation state. And over on the right hand side, I want to change the variable type. And I'm going to search for the enumeration that we just made, and that was called enum underscore animation states. So I'm going to select that, compile and save. Once I've done that, I can drag in my animation state variable and choose set. Here I can set my animation state to any of the idle, run and jump states that I created. Now because is in air is true, I want to set my animation state to jump. The next step is to grab is moving, just like we did with is in air. I'm going to pull that in and choose get, pull the red pin out, search for a branch, and then from the false condition, that's going to then check our new is in moving branch. If it is true, we're going to get our animation state, choose set, and then choose our animation state to be run, plug that into true, and then the last one, I'm going to grab that enumeration again, choose set, and this time I want to set it to idle, which it should be by default. So our logic says, right, if is in air is true, set the animation state to jump. If it's false, check is moving. If is moving is true, set it to run. And if is moving is false, set it to idle. We're going to take all of the outputs here and plug them into our return node, like so. And the last thing we need to do is get a select node, which is going to select from our flipbooks to determine which flipbook is going to be sent out to our character. So I'm just going to right click underneath the return node and search for a select, like so. These are going to be just blank for now, and we have an index which is a wildcard, which means I can drag anything in and plug it into our select. We're going to grab our animation state variable, drop it into the index, and you can see that our options now change from idle, run and jump. These are all wildcards, which means they can become anything. So if I take my return value and plug that into the output flipbook, you'll see that these now change into flipbook object references, which means I can just select which flipbook I want to plug into idle, run and jump. So obviously for idle I'm going to choose the idle animation, for run I'm going to choose the run animation, and for jump I'm going to choose the jump animation. We can compile and save that now. So that's our animation state machine done. You can neaten this up if you really want to. I'm just going to leave mine as is. We shouldn't need to come back to this unless there's something wrong. So if I go back to the event graph now, on the end of our tick event, I can bring in our animation state machine function, plug it in to the end of the tick event, and then from here I'm going to take the output flipbook pin, let it go, and choose for set flipbook. It's going to automatically plug in the sprite component. Apologies, move that down there, and we should be good to go. So I'm going to compile and save and press play. We'll just give it a check. Okay, the character idles and runs as is necessary, and then also jumps as well. The jump height is quite low, so I might fix that later. One thing that I'm also noticing is I've got some rendering settings on which are causing things like motion blur and some anti-aliasing, so I might want to fix that. So I can go into the project settings now. Again, if you can't remember what that is, just go settings, project settings. I'm going to scroll all the way down till I find rendering. In the rendering section, I'm going to keep scrolling down until I find default settings. And generally when I'm working in 2D, I tend to turn all of these off. So ambient occlusion, bloom, ambient occlusion, the other ambient occlusion, auto exposure can be turned off. We can leave that on. I'm going to turn motion blur off, and then anti-aliasing method I'm going to change to none. And then when I go back and press play, you can see that our sprites are a lot more sharp, a lot more clear now. The motion blur is gone. We don't get that weird effect when we turn. Yeah, looking alright, quite happy with that so far. Press escape. I am going to tweak my character's jump height very, very quickly. So I'm just going to come back to my character, select the movement component. I'm going to change my jump velocity to 1500 and just see, yeah, okay, that feels a little bit nicer to me. Alright, so we've got our character done, we've got our animations done. I guess the next step is to set up our tiles for building a level. So we'll just do that very, very quickly. So back to our main screen. At this point I think it's a good idea to set up a level that we can use permanently. We've just been using a default level. So to do that, I'm just going to go back to the content folder, right click, choose a new folder, call it levels. I'm going to go file, new level. I'm going to choose a default level. It looks the same, but essentially that just allows us to make sure that it's all fresh. If we've done anything to the old one, we've got a brand new one. And I'm going to choose save current. Save current means it's going to save the current level. I'm going to choose my levels folder and I'm going to give it the name of level 01. Do remember the name of this, it is important, so please try to follow my naming conventions. Even if I'm using capital letters and underscores, it does become important later on. So when I save that, we can dive into our levels folder and you can see that we've got our level saved. Now to make sure that this level is the level that we use by default all of the time, I'm going to go back to project settings. I'm going to choose maps and modes from the beginning, from the top, and I'm going to set the default maps to level 1 and level 1. That just makes sure that when the game starts or when you reopen the editor after closing it, this level will be loaded up automatically. Okay, now that we've got that in place, we can set up our sprites for our level. So we're going to go into the sprites folder, into the terrain folder. This is our sprite sheet here. I'm just going to double click this so you can have a look. These are the tiles that we're going to use to build our level. So first things first, let's right click on our terrain, go sprite actions, and we want to create a tile set. Let's double click to open up our new tile set. The current tile size you can see is set to 32 by 32, which is too large. You can see that things don't fit correctly. So we're going to change that from 32 to 32 to 16 by 16. Now you can see we can select each of our little bits of the tile set more appropriately for what we need. The next thing is to add some collisions to our tiles. So I'm going to turn on colliding tiles, which means we will see any collisions that we've set. And to add a collision, it's very, very simple. I'm just going to select a tile that I know I want the character to collide with and just add a box. So I'm just going to use these sort of grassy ones for now. I'm just going to add a box to all of these. This is like a decorative piece, so I don't need any collision on that. And I may well use this as a bridge or something perhaps. So I'm going to select that one, choose add box. You can see that the collision box around this is too large. So I can just select this bottom edge and just drag it up so that it fits more tightly, so the character won't bump their heads way below the actual pixels. So that'll do. I'll press save on that. Of course you can add more collisions to your tiles, use different ones, that's entirely up to you. Alright, we're kind of done with the tile set for now. We can always go back and change some of these things later. Close that down, back to our main window, and now we're going to create a tile map from our tile set. So on the tile set we're going to right click, choose create tile map. I'm going to open that up and have a look at what's going on there. So we've got our palette over here on the left hand side, and we can choose any individual tile to paint with, or we can actually select a group of tiles and paint with multiple at once. So for instance something like this, we would use a group. If I were to create a single platform, I could just use that. Obviously you can see right now that the tile map itself is very, very small, so we're going to need it to be a little bit larger. So over on the right hand side we've got the setup here for map width and map height. Don't confuse that with tile width and tile height. We need to use map width and map height. So for the width, I'm just going to give myself plenty space to work with. You can see that it actually adds tiles to the right. Now if you change the tile height, it's going to add tiles going downwards, so just keep that in mind if ever you want to readjust the height of your map. I'm going to go with 400 width with a height of 100, and that should give me plenty of space to work with. I do want to make sure that I leave plenty room down the bottom to add things like pits without the camera going so low that we actually see the bottom of the tiles here. So I don't really want to use the bottom. I'm going to kind of start in the middle. Likewise, you know, like the camera is going to start somewhere around here, so I'm going to leave a lot of empty space, or at least space that's been filled in, so that we don't see the edge of our tiles there. So with that in mind, I'm just going to make a start. I'm going to work on one layer at a time. We'll add layers as we go. So I'm just going to select this part of the tile set, which is the floor, and I'm going to paint in. I'll start there. I'm going to zoom in with a mouse wheel, and I'm just using left click to paint in some floor tiles here. Just checking to see how much space I'm using here. Right, that'll do. I'm going to choose this corner piece now and put the corner on, and then the edge of the wall. I'll just paint down here. If you make any mistakes like that, you can just choose the eraser and erase anything that is a mistake. Go back to the paint tool, and there we have the start of our level. I'm going to choose this piece in the middle, choose the fill tool, just click here, and that's going to fill in everything on that area that we've defined there. Next I'm just going to put a little bit of decoration, so I'm going to grab these sections here, back to the paint tool. I'm just going to plop in some little decorative pieces there just to add some variety to our tile map. And again, okay, now I might put some platforms here just for the sake of it. You can design your level how you wish. So I'm just going to choose, I tell you what, I think I don't really want my tiles, my platforms to be 3 by 3, so I'm going to just paint in a corner piece, let's say there, and then 3 middle pieces, and then an edge piece, and then I'm going to get the bottom corners and put those in, and then fill in with some bottom pieces. So I'll just put in 1 or 2 platforms here, just so you get the idea, and then of course you can paint in your level as you see fit, and then I'll put another bigger platform up here. Forgot the corner piece, let's put that in. And I'll just fill that. So we've got the start of a very, very simplistic level. Right, okay, that's great, fantastic. Oh, let's put some little decorative bits and pieces in here. Back to the paint tool. I don't like the way I've done that, so I'm just going to Control Z. Doesn't look very natural. But yes, you can do this however you see fit. It's entirely up to you. Right, that will do for now. So that's one layer. Obviously you're going to want to create multiple layers to add depth to your level, and I'll just explain a little bit about that as we go. So I'm going to save that tile set, that tile map. That now becomes an asset that we can drag into our level to replace this lovely little platform that we've got here. So what I'm going to do is I'm going to select that platform, press delete on the keyboard to get rid of it, and I'm going to drag in my tile map. What I'm going to do right off the bat is I'm going to show you very quickly that it's not lined up with our player start point. So I'm going to go over to its location and set that to 0, 0, 0, which is going to take the very top corner of our tile map and put it at 0, 0, 0. You can either just drag this up, or you can move your player start point to match. Now the first thing that I'm going to show you is that our character, because we scaled it up but to 555, is now significantly larger than our tile map. So to rectify that, I'm just going to select the tile map, select its scale, and put it to 5, 5 and 5 on the X, Y and the Z. It does mean that I'm going to have to zoom out a bit and just nudge it up a little. I'm going to select my player start and press F to zoom in. And what I can do here is just press the end key and it'll snap down to the nearest sprite underneath it. If I press play now, you can see that it's nicely matching the scale of our character. So I don't like the way my character is spawning right on the edge of this world here, so I'm going to move my player start point over and check. Right, I can no longer see the edge, but it is very close. So I'm just going to move it over a little bit further, and then our character starts in a decent place and we can start exploring. Obviously my character can't jump high enough. I suppose what we could do is set up a double jump if you'd like to do that, or we could just change the height of the jump. I'm going to put in a double jump just to show you how to do it. So I'm going to go into my player character now. I'm going to choose self at the top, and just to make this nice and quick, at the very top here we can just search for jump. The value that we're looking for here is actually just called jump max count, but if you ever need to find something, you can just search for it at the top there. So if we come to the top, under character, you can see jump max count, and I'm going to change that to 2. Compile and save that, press play. I can now double jump, which is allowing me to reach these previously unreachable jump heights. Lovely, alright. Okay, so that's our tile map started. Let's start adding some layers now. So over on the right hand side, I'm going to add a new layer. First of all, actually, before I do that, I'm going to rename my first layer. I'm just going to select it and press F2. Oops, I opened up the help page. Press F2, and we're going to call this layer the playable layer. So this is the layer that we'll put everything on that we can interact with. Let's add a new layer which automatically goes to the top. We'll call this the FG for foreground, and let's add another one which will go to the top. we'll call this BG for background, and we want to move that one to the back, so I'm just going to select it, press the little down arrow, and that's going to move it to the back. Okay, so we've now got a foreground layer, a playable layer, and a background layer. I'll start with the background layer, and I'm just going to put something, I'll put these bricks in, and they're going to go on my background. So I'm just going to put some like sort of brick columns, just to give you some idea of what you can do with this. So I'll put one starting there, and I'm going to choose to paint a column here. Now if you go behind your playable layer, you can just select it, use the eye icon to turn it off, and then go back to the background layer again. And I'm just going to paint this down to the bottom like so. I'll turn this playable layer back on, and I'm just going to put another couple of columns in, really just to help demonstrate what we can do with the use of the perspective camera. Oopsie daisy, we'll fix that in a second. Woo-hee. Okay, let's zoom in so I'm a little bit more accurate. There we go. Just fix these errors. You do need to make sure that you do have the layer that you are wanting to paint on selected. That's quite an easy mistake to make. Right, let's put some stuff on the foreground layer now. I'm just going to put some of these in. Again, columns. I'm just going to put columns in. This is really just to give you an idea of, you know, what these layers can do. So I'll start here, and I'm just going to paint in some of these. These could be like I don't know what they are, but it'll do for the demonstration. Oops. Oh my gosh. Oh dear. Okay, that will do. So if I save this now and go back to my level, you'll see that we have some layers in play now. If I just select the tile map, you can see that it has 3 separate vertical layers. What it has done is it's offset now. So what it's done is it's kind of moved back. So the very first layer, the foreground layer, is at 0, which means that our middle layer has been pushed back a little bit, which basically means our player is no longer in line with the central layer. So what I need to do is select my tile map, and I'm going to need to move it forward. Now another thing that I would like to do is increase the distance between these layers to give us that nice perspective effect. So to do that, I'm going to go back to the tile map, and where we have over here on the right hand side, we've got separation per layer. It's currently set to 4. I'm going to change that to a much higher number. Let's try 50. And let's go back to our level, and you can see now that our layers are much further apart. That's going to give us a greater sense of depth. So what I'm going to do now is, this is really if you're just using a perspective camera, by the way. This changes completely if you use orthographic, but we're just going to use perspective for this project. You can see now that those layers are much further apart. So I do need to, my player, if I press play now, will just plummet, because it is no longer in line with our colliding playable layer. So I'm going to move my tile map forward so that the middle layer is in line with our player start. So I'm not quite sure about the number on this, so what I'm going to do is I'm just going to choose the y-axis. I'm going to give it 100 on the y, which is not close enough. Let's give it another 100, whoops. And we're still off, I think, to 50 is perfect, which it is. So you can see now that our player start is now realigned, and if we press play, we get this nice sense of depth, whereby the foreground is moving quickly, the background is moving slowly, and the middle ground is level with our player, and it just, whoops, gives us a nice feeling of, sort of depth within our 2D world. Alright, cool, so that's our tile map done. Our level is set up. The next step really is to set up some hazards for spikes. So we'll put our spikes in, and then we'll put our falling pit trap thing kill volume, so that when the player falls down one of these pits, obviously they die. Okay, so just quickly, I figured we might as well stop the character from being able to do this, which is to run off to the left to the edge of the world, which we do not want. So to stop our character from being able to do that, we're going to use something called the blocking volume, which you can find over here on the left hand side. If you just choose volumes and then drag in a blocking volume and just make sure that it is in line with your central layer of your tile map, you can see now it will stop the player from moving over to the left, but it's not tall enough to stop the player from jumping over it. Not ideal. So with that blocking volume selected, if you do deselect it and you find it a hard time selecting things in the level, you can always select things from your world outliner over here. You can see there's the blocking volume there. If you just scroll down here, you can find the brush settings, and then in the Z value, I'm going to turn it right up to 1000, and as you can see, the player has absolutely no chance of being able to jump over that. You could always add like an object there as well, so there is like a physical barrier that's going to kind of stop the player from moving over, but that's entirely up to you. Right, the next thing is to set up the spikes. So let's extract our sprites first. So we're going to go into the sprite folder, into traps. You can see there's lots of them here, but I'm just going to choose the spikes, and I'm going to right click, sprite actions, and extract sprites. I do not want these individual spikes, so I'm just going to change it from auto to grid and then extract it, and we get a single sprite with 2 spikes on it. The next step is to set up our blueprint. So let's go to our blueprints folder. I'm going to right click, blueprint class. This time I'm going to choose an actor. So let's do that. I'm going to call it BP underscore spikes. I'm going to double click to open it up, and I'm going to go back to my sprites folder, traps, spikes, and I'm going to grab my sprite, drag it in, hover over the tab at the top there, and just drop it into my blueprint. I do need to scale it up to match everything else that we've done so far. So on the scale, 5 in the X, 5 in the Y, 5 in the Z, and then I'm just going to drag it up so that the bottom of the sprites is level with the center of the root of our object. That will do. If I just compile and save that now, I can drag in, so back to blueprints, I can drag in my blueprint for the spikes. I'm just going to make sure that its location is exactly 0 on the Y to match everything else. And I can hold, if I want to make more of these, I can hold Alt and just drag out copies. So for the time being, if I stand on these sprites, I collide with them in the sense that I'm being blocked by them. You can step up onto them, but this is not what I want to use for registering the collision with our spikes. I want to set them so that I overlap rather than hit. So I'm going to go back into the blueprint. I'm going to choose the sprite, select the sprite from the components list, move over to the details tab on the right, and I'm going to scroll down till I find collision, and I'm going to change the collision preset from block all dynamic to overlap all dynamic. Compile and save that, press play, and you can see now that I can run through the spikes. Okay, let's get some programming done on this thing so that it behaves the way we want. So into the event graph, I'm going to get rid of those default nodes, we don't need those. I'm going to select my idle sprite from the components list, right click, choose add event, and we're looking for the event called add on component begin overlap. From there, I'm going to take the white pin out. I'm going to type in cast2 and then the name of my player character, which is BP underscore player character, and then I'm going to take the other actor and plug that into the player character. That's basically checking to see that if the thing that has overlapped with our sprite is the player character, and then we can do something with that. We will get our character to do something with that collision. For the time being, just to check that everything's alright, I'm going to take this execution pin out and I'm going to use a print string. So our logic basically says that when we overlap with the sprite, check to see if it's the player character, and if the cast is successful, print string the word hello. So when we hit our spikes, we get hello in the top left hand corner, so we know that everything is working as intended. We can get rid of that print string now. Okay, so now what we need to do is send a message to our player character to say, right, do something when you collide with these sprites. So let's go back to our player character. In a bit of empty space, I'm going to right click and I'm going to search for custom event. I'm going to create a new custom event, and I'm going to give this custom event the name of death. Okay, let's compile and save that. Now from here, this is where I want to tell my character to do things as a result of dying. Okay, so like when you hit the spikes, I want the character to be able to, I want it to stop moving, I want the animations to stop, and I also want the character to turn red, and then we're going to add a camera fade, and then later on we'll get the character to spawn back in again. So from here, let's take the white pin out, and we are going to disable input. With the disable input, we need to say which controller is going to no longer input. So we just take the player controller pin out and search for get player controller and plug that in. So we'll compile and save that. It's not going to do anything yet because we haven't told this event to start anywhere. So if we go back to our spikes, we must compile the player character, by the way, we must compile it. Go back to the sprites, the spikes, and take the as BP player character 01 pin out of the cast and search for the death event that we just made. So that basically means that when we collide with the sprites, cast to the character and then make it trigger off this event called death, which means anything that we put here is going to happen. At this point, it's just going to disable input. So if we run into our spikes now, input has been disabled and we can no longer get our character to move, but there's other things that we need to do as well. So let's also, I'm going to add in we may need to reorder things, but we'll see. I want to disable movement as well. So we're going to disable movement, which means that so basically, let me just undo that just to show you why we're doing this. So if I jump onto my sprites, I still continue to travel downwards, and I'll just hit them. You can see that I continue down to the ground, but with disable movement in place, I no longer carry on down to the ground. So now let's stop the animations from happening. So there's two things that we need to do here. First of all, we need to set the play rate of our animations. So set play rate is what we're looking for there. We're going to set the play rate to 0. You can see that it pauses the animation there. But the problem that we have is that because we're stopping movement, it's also defaulting to the idle flipbook. So we need to stop all of our checks from happening here to stop our animations from updating. So in order to do that, we need to add a new variable, which we will call isAlive. We must change that variable type to be a Boolean. Press compile and save that. We want the default value of that Boolean to be true. That's important. It must be set to true, otherwise your animations will stop working. What we're going to say is right at the start of our event tick, we're going to get the isAlive. So drag it in, choose get, pull the pin out and search for a branch. We're going to plug our tick into there, and we'll say, right, if isAlive is true, then we can do all of this stuff here to sort out our animations, to set our animations. And then when we die, we want to set, so choose set isAlive to false, so we don't tick that box there. So as soon as death happens, isAlive becomes false, which means nothing is going to happen from this tick event. So if we compile and save that, press play, if we just land, you can see now that the animations stop updating. So you can see it's frozen on the run animation there, and it just gives information to the player that something bad has happened. Let's have the sprite turn red. So we'll drag in our sprite component. This is on the end of our death sequence, not the end of the tick sequence. So let me grab all of this and move it down. Here we go. So on the end of death, from the sprite component, let's search for set color. It is spelt without a U, by the way, so if you type in color with a U, you won't find it. Let's plug that in, and the color that we want to set it to is obviously going to be red, so I'm just going to drag these two bars up. Press OK, compile, save that. So now when we die, our character turns red, and it's just another way of, you know, communicating with the player that something bad has occurred. The next thing that we want to do is we're probably going to want to fade the camera out. So in order to do that, we shall drag in our camera and take the pin out, and we want to start. How do we do this again? Oh, sorry, yes, don't drag in your camera. That's my mistake. So don't drag your camera in. Right click, and we want to get player camera, and we're looking for get player camera manager. Pull the blue pin out of there and search for start camera fade. Plug that in. Here we've got some values that we need to change. So the alpha is how dark the screen is. So 0 is no darkness whatsoever, it's all transparent, and 1 is fully black. So we're going to fade from 0 to 1 over a duration of 1 second. Compile, save that. Let's test it out. Okay, you can see that it instantly started doing it, and then when it finished, it went back to normal. So what we might want to do is to put a delay in there so the player has a moment to process what's just occurred. So I'm going to hold D on the keyboard, left click to add a delay. I'm going to plug that in, must make sure to plug it in, and that goes in between the sprite color and the start camera fade. Let's give them a duration of a second for that delay, and then to make sure that the black fade stays black, we have to turn on hold when finished. So we'll compile, save that, press play, we wait for a second, the camera fade starts, and then it stays black. Lovely. The next thing we need to do is to spawn our character back into our level. So we're going to destroy our current character and then respawn a brand new character back at that player start point. And to do that, we're going to use our game mode blueprint to do this. So we'll go find our game mode blueprint in our blueprints folder. There it is. We'll double click to open it up. This is the window that I was talking about earlier. If you do see this, just click open full blueprint editor. There we go. Let's get rid of these two events. We don't need those right now. What we are going to do is create another custom event in our game mode. So we're going to right click and search for custom event, and we'll call this custom event player death. So what we're going to do is when the player dies, it's going to send a message to the game mode to say, right, the player's dead, you need to respawn a new one in. So we'll compile and save that, go back to our player character. On the end of our death event here, so death, on the end of here, we are going to cast to BP underscore game mode. We must have an object reference, so if we take that object reference out and search for get game mode, and then as game mode 01, we are going to fire off the player death event. Right, unfortunately I got that bug again, so I had to pause the recording and restart, but we're back in now. So yes, we're going to fire off that player death event. So when we die, we send a message to the game mode to say the player is dead. The game mode will receive that information and then do something with it. I guess, you know, like what we want to do is destroy our current player character. So what I could do is from player death, take the pin out. This is on the game mode. Cast to BP player character. For the object reference, we need to get player character. Whoops. Get player character. And we want to destroy actor. So that will destroy our current player. Now, what's going to happen here is, like, if we do that right away, it'll wait for a second, and then as soon as the camera fade occurs, it destroys our player, which means our camera defaults to that one. So let's not do that, and we want to wait until the camera fade is completely black before we destroy the player. So let's put a delay here. Let's wait 2 seconds. That's a 3. Let's wait 2 seconds so that our camera fade has enough time to actually occur. So we'll wait for 2 seconds now before we destroy our player, which means the screen will go completely black, and then whilst it's black, the player character is destroyed. Once it's destroyed, we need to spawn in a new one. So from destroy actor, let's go spawn actor, can't type, spawn actor from class. Here we need to choose what actor we would like to spawn. So let's select class and let's search for our BP player character 01. And the next thing is we need to say where do we want it to spawn. Now we want it to spawn at our player start point. So to do that, I'm just going to right click down here, search for find player start, and then we need to get the transform of our player start. So we'll take the return value and we're going to get actor transform, and then we can plug that in to our spawn transform. Once that player character has been spawned in, we need to tell our player controller to possess that new character. So let's right click and get player controller, take the pin out and search for possess, plug that into our spawn actor, and then we must say which actor we want to spawn. So we take the return value from our spawned actor and plug that into the in pawn for the player controller. So our logic at the minute is when the player dies, wait for 2 seconds, cast to the player character, destroy it, spawn in a new player character, tell the controller to possess that player character, and then we want to obviously reverse our camera fade as well. So let's right click and search for get player camera manager, take the blue pin out, let's go start, and you can select start camera fade, plug it in. This time we want to make sure that we spawn, we interpolate the alpha from 1, meaning it's all black, to 0, meaning it's not black at all, over the course of 1 second, and hold when finished is ticked. So let's see what happens now. So we die, we wait, the camera fade occurs, and then we respawn our player back in and we reverse our camera fade. Fantastic. Alright, so we've got our first death condition set up. The next one is to set up some kind of volume down here so that when the player falls in there, they die. So let's compile and save our game mode, and we'll go back to our main level and let's set up a new blueprint. So we're going to right click in our blueprints folder, blueprint class, actor, we're going to call this BP underscore kill volume, and then we'll double click to open that up. Inside the kill volume we're going to add a component which is a box component, box collision, compile, save that. What we can do at this point is we can drag this into our level. So we'll go back, drag in the kill volume, make sure that it is definitely going to be big enough to catch our player. So I'm just going to press R on the keyboard to get the scale tool on, and really, like, you could put this across your entire level, you know, so it spans everything, or you can just place individual ones. That's entirely up to you. You can drag as many of these into the scene as you need, but that will do for me. I'm just going to leave mine in that position for now. So I'm going to save my current level. Okay, so let's go back to the kill volume, into the event graph, get rid of these default nodes. I'm going to select the box, right click, add event, on component begin overlap, and take the pin out. I'm going to cast to my BP player character, and plug in the other actor, and like we did before with the sprites, let's just check by adding a print string that says hello if we collide with our player. So because this is here, when we fall off the end, when we collide with it, it should say hello. So let's test that. It would help if I didn't run into my spikes, so let's just jump over those. Yes, we got a hello in the top left hand corner, so fantastic. So just like we did with the spikes, sorry, we need to set up a custom event that does some things when the character falls into the kill volume. So let's go back to the player character. Just underneath our underneath our death event, I'm going to create a new custom event, which I will call fall death. And this is the event that we want to trigger when our player falls into the kill volume. So let's compile and save the player character, go back to the kill volume, get rid of the print string, and then as player character 01, we want to trigger fall death if we fall into the kill volume. So let's save that, back to the player character. What we want to do here really is essentially everything that we've done up here, minus things like disable movement. I'm not too concerned about making it red. I don't really want to stop the play rate either, so I think what I'm going to do is just move this over. What we want to do is we want to detach our spring arm from our player so that when we fall in the pit, the player continues to fall, but the camera does not. So I'm going to get the spring arm, drag that in, pull the blue pin out, and search for detach. And we're looking for detach from component. We'll plug that into the fall death. The location rule is the only thing we want to change. So we're going to say, right, change that to keep world, which basically means that wherever this happens, it's going to keep the spring arm and therefore the camera exactly where it is in the world. Another thing that I want to do here is disable input as well, because I don't want my player to be able to jump back out of the kill volume once they've gone in there. So I'm going to just take the blue pin out of, the execution pin, the white one, from the detach component and search for disable movement. Disable input, not disable movement. We definitely want the character to continue moving. And then in the player controller, we need to get our player controller and plug that in. And then from there, I can just sort of tap into what we've already done up here, because I do want the camera to fade once we've fallen in. So I don't need to rewrite any of this. I can just take this execution pin and plug that into the delay, so that when the fall death occurs, it detaches the spring arm and the camera. It'll stop the player from being able to add any input through the keys. And then it'll wait for a second, and then it'll start the camera fade. It'll tell our game mode that the player is dead, and then of course the game mode will destroy our character after 2 seconds, spawn a new one in, possess it, and then start the camera fade in reverse. So what we end up with is our spikes are exactly the same. We run into there, we get everything looking great. We can jump over those, and then if we miss time and jump, oh no, fall in, player character falls, and we're respawned back into the level. So the very last thing that we need to do in terms of like our actual gameplay is an end to the level, like a goal to work towards, something that's going to register the fact that we've finished the game level. So we're going to go back into our blueprints folder here. I'm just going to put my end goal up here somewhere. So I'm going to right click, create a new blueprint class. This is going to be an actor class. I'm going to call this BP_goal, and then I'm going to double click to open it up. I'm going to add in a new component, which will be a box collision. Compile and save that. I would like to add some sprites in here, and to be honest, I would quite like to make this end goal big enough, just like the blocking volume, that the player can't possibly miss it. So with the box selected, I'm just going to set the box extent to 1000, so that it's extreme. That might be a bit excessive to be honest, but that's okay. Let's take that down a smidge. Let's say 500. I mean, that is still excessive, but it's fine. Alright, I'm going to take it down to 200. I just want to make sure that the player can't miss this. They can't jump over it, for example. So I'm going to set it up like that. So 200 on the Z, and I just lifted it up a little bit. I'm going to add some sprites in here as well. In fact, I'm going to add an animated flipbook because I think it looks nicer. There is something that you can use if you go into sprites, and I believe it's in items, checkpoints, end. There is like a nice animated trophy that just does the job nicely. So let's extract these. So I'm going to right click on that sprite sheet, sprite actions, extract sprites. I don't want to do it in the auto style, so I'm going to go to grid, and I'm going to change the width to match the height, so we get individually extracted sprites that are all the same size. Extract that. I'm going to select all of my new sprites, right click and create a flipbook. I'm really not bothered about naming this, but you can if you wish. And then I'm going to drag my new flipbook into my goal blueprint and just drop it here. I need to scale it up to match everything else, so with it selected in the scale, 5 on the X, 5 on the Y, 5 on the Z. I can see that it is way bigger than my collision box, so I might want to do something about that. So I'm just going to drag it up so the bottom is level with the root. And then actually I've accidentally parented my sprites to my box, which means if I start scaling things it's going to cause me an issue. So I'm just going to drag my sprites back onto the box so they're no longer parented. And then I'm going to choose the box, and I'm going to just make it wide enough to kind of roughly match the, maybe a little bit like there. I think that'd be nice. So I'm going to compile and save that, and then I'm going to go back to my blueprints folder, and I'm going to drag my goal into my level, and I'm just going to set its location on the Y to 0 so that it's nice and level with my terrain, with my sprite tile map, sorry. Okay, so it's there but it doesn't do anything yet. Okay, so just like we did before, into the BP goal now, into the event graph, get rid of these default pins. On the box, must be on the box, I'm going to right click, add event, on component begin overlap, just as we did before. Cast to BP player character 01, other actor goes into the object reference. Let's put in a print string just to be sure. So it's going to say hello when we hit that end goal. Let's go running on over, an opportunity to play my game, and we get hello every time I collide with the end goal. So just as we did with our kill volume and our spikes, let's go back to the player character. I'm going to set up another custom event. So just in a bit of empty space, custom event. I'm going to call this goal reached. And we want to do some stuff as a result of that event. So the things that we want to do, well, first of all, let's go back to the goal blueprint and make sure that we fire off that event. So let's get rid of the print string, and as BP player character 01, fire off the goal reached event. Back to the player character. Okay, so when we have reached our goal, let's disable input again. Don't forget to plug in the get player controller into the player controller for disable input. This is again going to stop our character from being able to move around when the keys are pressed. What else can we do? We can have it like do something like jumping up and down as a result of like a little celebration, right? So right now what will happen, I'll tell you what I'm going to do just to test this. I'm going to move it to the start of my level because it's going to take me a long time to keep checking that. So let's jump over, we hit it, and I can no longer move, which is great. So let's go back to the player character. If we wanted to jump up and down, we could add like a delay for like 1 second, plug that in, and from the delay, let's say jump. And just a quick and easy way of like getting this thing to loop would be to take the execution, bring it up here, search for RERO, which is to add a reroute node, and then we can loop it back round again. And you'll see what happens is when we reach the end goal, our character will just, I'm not pressing any buttons there, will just automatically jump up and down. I don't like the way the camera's moving, so I'm going to just squidge all this along a bit. And just like we did earlier, I'm going to detach my spring arm. So spring arm in here, and detach from component, plug that in, and change the location rule to keep world. So now the character will jump up and down with the camera detached, which I think just looks a lot nicer. Okay, great, so we've got our end goal there. The last thing we need is a menu screen at the start of the game and a menu screen at the end of the game as well. So let's set up some widgets for our menu screens. So I'm just going to file and save all, just to make sure I don't lose any work if anything terrible were to occur. So in the blueprints folder, we can just do this in here, that's fine. Let's right click, search for user interface, which is at the bottom, and then widget blueprint. I'm going to call this one widget w underscore start menu, and then we'll double click to open it up. So when you're working in widgets, it's separated into designer and graph. Designer is where we do our layout, graph is where we do our sort of functionality. So let's just grab some text, plonk that in here. We're going to change this to super, so over on the right hand side with the text box selected, under content where it says text, we can put in whatever text we want. So I'm going to change this to super amazing game. And once I click away, you can see that updates. I can reselect that and scroll down a little bit. I'm going to change the justification so that it is aligned to the center. I'm going to open up font and change the size by just dragging it over. That will do. I can change the color here by clicking on this color box, so maybe a nice kind of blue color. Press OK. I can open up the outline settings and add an outline to make the text kind of stand out a little bit. I'm just going to set mine to 3. If you want to change the outline color, it's just here. I'm going to leave mine as black. So there's my title. Obviously you can use like custom fonts and images and things like that, but just for this quick demonstration we're just going to stick with text. Okay, let's grab a button. This is going to be our start game button, so I'm going to drag this in and I'm going to scale it up so it's rather large and kind of place it in the middle there. And I'm going to grab some text, drag, drop that into our button so that it attaches to it. And the text for this one, I'm going to say, right, I want this to say play. I'm going to make it a smidge bigger, not that big, it's crazy, right, that big. And then I'm going to change the color to black. And let's give it an outline, 3 again, and I'm going to change the outline color to white, just to make it look a little bit nicer. So we've got a button now and a title. Fantastic. Let's compile and save that. So we want this widget to appear as soon as we play our game. So let's get our game mode to handle that. So let's go to our game mode blueprint. I'm just going to get rid of, so I don't need that kill volume anymore. I am going to need the goal, and I do need everything else, so I'll just get rid of that. Okay, so back to the game mode blueprint now. And okay, we're going to use an event called begin play. So this event will kick off as soon as we press play. So let's right click and search for, got to spell that correctly, begin play. So from our event begin play, first of all we want to, let's create that widget. So create widget. We need to say which widget we want to create. So where it says class, we want to create our start menu. And for the return value, we'll take that pin out and we'll search for add to viewport, and that's going to make sure that when we press play, our widget is created and added to the viewport. Let's press play, but we have a problem. We can still play our game, not ideal. So what we'll do here is we are going to take out the pin from add viewport and search for set input mode, and we want to set input mode UI only. We do need to plug a player controller into this, so let's take the pin out of there and search for get player controller, press compile and save. So this basically means that all of our input will only apply to any UI that's on the screen. So now when we press play, the UI appears and we can no longer interact with the game, only the UI, but you can see that we don't have a mouse cursor, but I can interact with the UI if I click. So let's get the mouse cursor on. So to do that, we're going to right click and get player controller. This is still in the game mode. On the end of our event begin play, we take the pin out of the player controller and we want to set show mouse cursor, and we want to set that to true. I have just noticed my UI bug again, so I'm going to pause this in a moment and restart. So compile and save, press play. We now have a mouse cursor from the beginning. We can't control our character, but we can't start our game just yet. So I'm going to pause this, fix my bug and carry on. Alright, back in action. So the next thing to do is to get our menu screen to disappear when we press the play button and allow us to play the game. So back to our start menu widget. We no longer need to be in the designer, so we're going to go to the top right and choose graph, and we can get rid of these default events. So over here we have our button that we created, and down here we have events that we can do based on what that button is doing. So we're going to choose on clicked, hit the plus button. So whatever we do is going to happen when we click the button. So first of all, let's set input mode to game only, and we need to plug in a get player controller into the controller reference, and that's going to allow us to move our character again. And then we also want to remove the widget from the screen and also get rid of the mouse cursor that we see. So let's get player controller, take the return value out and set show mouse cursor. This time we want it unticked to make sure the mouse cursor goes away. And then lastly, from there, let's remove all widgets, which is a bit of a cheap way of doing it, but it works nonetheless. So when we click the button, we set the input mode to game only, we turn the mouse cursor off, and we get rid of any widgets that happen to be on the screen. So let's try it. We've got a mouse cursor, we can't move. We press play, mouse cursor disappears, and we can start playing our game. Now we just need one more for the end of the game, and we're done. So back to our main window again. Let's make another widget. So let's go right click, user interface, widget blueprint, W_end menu. Double click to open it up. Very much like we did before. Let's just get some text, drop that in there. On the right hand side, let's type in level complete, exclamation mark. Let's make the text big. Let's set the justification to be in the center. I'm just going to align this so that's in the middle. You can type in exact numbers, but I'm not going to bother. Let's change the color. I'm going to go for something different this time. Kind of, I don't know, green. Let's go green. Green is good, right? Level complete. Press OK. Let's put an outline, black outline on it. And then we want a button for replay. So let's grab a button, drag that in. Just going to scale that up. Grab some more text, drag it onto the button. Let's put some text in there. So I'm going to say replay and change the color. This time I'm going to go black. Let's make it a bit bigger. Let's put an outline on there, and we'll make the outline white again. There we go. Cool. Brilliant. Right, let's compile, save. Where shall we handle this one? So the game mode added our widget last time. Let's do it for the player, because on the player we have a goal reached event. So what we need to do, we can't come off this loop here, right? Because that's going to just carry on looping round and round and round. So let's add in something called a sequence. So from our detach spring arm on the end of, so in the middle of goal reached, I'll tell you what, we could just pop it here, actually, thinking about it. Yeah, let's not put a sequence in, let's just put it here. So right at the start of goal reached, we are going to create the widget. Let's create the end menu. I'm going to actually get rid of this disable input and replace that with something else, but let's add this to the viewport first and foremost. So return value, add to viewport, and we are going to set our input mode again. So set input mode UI only, plug that into there. Let's get our player controller reference in there, so get player controller, compile, save that. Let's test it. We should now, when we reach the end goal, have our menu screen pop up. We can only interact with the UI, and then everything else carries on as it was. So play, jump over the spikes. Okay. We do need to stop our character from moving, so that's not ideal. Hopefully this will still work. Maybe we shouldn't have deleted the disable input, right? So let's disable input right at the start again. So disable input, get player controller. We'll put that back in, compile, save. Hopefully that will still work. Lovely. Oh, we haven't shown our mouse cursor. My mistake. So let's get our mouse cursor back in. Let's do this after the input mode. So let's take the pin out. Let's right click and search for get player controller. Take the pin out. Set show mouse cursor to true. Okay, so now when we reach the end goal, we disable input to the player character. We add our widget to the screen. We create it, add it to the viewport. We set the input mode to UI only. We turn our mouse cursor on. We detach our spring arm from the character, and then we've got this loop that makes our character jump every 1 second. So let's test that. Jump. Hit the end, can't move, and we can interact with our menu. And the very last step at this point, other than putting sound and music in, which we won't bother for this particular project, is to get the game to start again, which is very, very simple. So we're going to do this in our end menu. We're going to go into the graph, get rid of these default nodes, just like we did before. We select our button, on-clicked, and then from on-clicked, hopefully this should just work, we're going to remove all widgets, and then from remove all widgets, we're going to open a level by name, and this is where that level naming thing comes in useful. We're going to open level 01. That is case sensitive, so if you've named your level with capital letters and things like that, you must replicate it here. So compile, save, the moment of truth. We end our level, we press replay, and we start all over again, and we have a very, very simple platformer game minus music and sound. So let's just play my entire level. I just wonder if I can jump over that. I don't think so. I'm going to try. I can. Okay. So I might want to, go back to the BP goal and just select that box. And yeah, maybe I wasn't overzealous. Let's make it real big. Player cannot possibly jump over that. So here we go. Final playthrough. We have spikes that can kill us. Oh dear, we're dead. We spawn back in. We have a pit that can kill us. Oh dear, we're dead. We spawn back in. And we have an end goal. I didn't test to see whether I can jump off. I know I can't, but Let's just test it anyway. Alright. No, I don't like that very much. Okay, we could probably fix that, but it's not too much of a concern for what we're doing right now. Alright, and that will do. That is your level, first level of your platformer game complete. I hope the video is useful for you. But yes, good luck. I hope it goes well, and I shall see you soon.